Today, the focus is going to be on this extract and linearize tool within HyperView. So not that it's necessarily advanced or difficult, just outside of the scope of what we covered in the basic session. So with that, I made this very simple model. It's supposed to look like a pipe. It's constrained at both of the faces, and there's an outward pressure being applied. I didn't take any real care to make sure the model was symmetrical or anything. I just needed something pretty quick to get this demo going. Once we have run something in OptiStruct, in this case, since I couldn't find a readily available abacus model for us to use, but the principles will be the same. I've already run this. I can come over here to where I submitted this job, and because the results file's in the same location, rather than opening a whole new HyperView window, we're just going to click HyperView, and this will open. You'll know you're in post-processing because HyperView is up here, and the very observant will notice, of course, that all of the icons have changed. So this is how it will come in. If you like to see the elements, which I do, you can turn on this to shade the elements. The first thing that we're going to do with this extract and linearize tool, we're going to say that we care about looking at the stresses through the wall thickness. I'm going to orient this and then just hide some of these elements so I can get a nice clean cross section. You can either select this or hit E to change the selection to elements, hit H to hide the elements. And now we have this nice clean cross section cut. I'm going to throw kind of an arbitrary contour on here, at least to start off with. I realize in this case, let's go here. I've had a lot more success with this tool when I'm using grid point stresses. So that's what we'll start off with. You'll notice here that X is actually along the length in the global direction. I'm putting this in X. We'll see why a little bit later on, just so I don't have to keep coming back to this panel, not because X is necessarily the right direction to be querying the stress results in for this particular part. So we'll start off here with global X, and maybe it will become apparent why later. The focus of this is on this. It used to be called, I think, extract and linearize. Now we've just changed it to linearize. And we'll start off with just the extraction part of this. So you'll choose what you want to do here. You'll notice the options change depending on which choice. So we will be an extract data, meaning that I am extracting the data that I currently have contoured. If I want to define a new path, 40 for this demo seems like a lot. We'll just go with 9 to start off with. I'll choose my starting point and my ending point. Before I actually produce this plot, it'd be nice if we could actually see what's here. Let me go to measure and actually turn on some of these. Because we're contouring nodes, grid point stress will have the option to label nodal contours. You can also do other things, but let's go ahead and just get everything along this path. There's not a lot. You'll notice that our line is not sitting exactly on these nodes, but these values should be very close. The only place it's actually sitting on the lines is the starting and the ending point. So we've got values that are on the order of let's say 25-ish when we resolve this in global X. So we'll head back over to linearize. It keeps our selection. We don't have to redefine it. Starting point and ending point, or vice versa. I don't remember which direction I selected. And then we ask it to put it in a specific layout. This preview plot is just going to bring up its own pop-up window. It'll be standalone. These other options are going to bring up hypergraph. It's up to you which one is more useful. Personally, I like to preview the plot, make sure that the results are what I want before I go into hypergraph and have to switch between hyperview and hypergraph to do stuff. So let's look at the preview plot. We pretty much see what we expect. Grid point stresses in global X. We start here at 26.8 and we extract these values, all only 9 of them in this case, until we get to the endpoint here, and then we interpolate at the values in between. Nothing particularly exciting there, we're just extracting what's on the contour. The reason that I am emphasizing this is because if we go here and say stress linearization, we get options to then resolve this in certain components or in invariants. So let's say that we take the same path here, and this time we want to do stress linearization. In this case, we're going to, again, preview the plot and see what it plots for us. We get this broken down into what we expect, this average or membrane stress, which is the average stress through the thickness. And then we also get a membrane plus bending line, and then the plot for grid point stresses. We notice here that this is not what's on the contour. So we're not just taking the contour here and linearizing it across the thickness. Internally, a local coordinate system has also been created. And I think it's just a good point to be aware of how these extract versus linearize, how these are pulling different information. If we wanted to check this against the contour, we would need to make a local coordinate system where X runs from here to here. So let's go ahead and do that just so we know how to make coordinate systems on the fly. We can right click and just create, and this will be a system. We can make rectangular, cylindrical, or spherical. We're going to keep it really simple here and just do a rectangular coordinate system. This will be my origin. This will be my x-axis. If you rotate that, make sure I pick the right node. And then we will choose y over here. Hit OK. And now we've got this local coordinate system that we can resolve our contour in. So let's head back over to the contour. Instead of resolving in the analysis or the global system, let's resolve in this new user system that we've made. This is going to be ID1. Hit apply. And maybe zoom back in here so we can actually see what's going on. This will be in X. And remember, even without this coordinate system, in the background, HyperView is still making that and resolving it in that coordinate system. Now this plot makes a little more sense. The values match up nicely. Our starting point over here at -16, and as we go up through the thickness, we end up at -1.5 as the endpoint on the blue line, which is the grid point stresses. A couple other kind of button clicks for the tool that I wanted to point out. We can go here, and like I said, we can do this and plot it actually in HyperGraph. It gives you some more options to export to Excel, to do some kind of curve manipulation if you need. So let's do that. So you get this separate window that pops up. When I click over and make this the active window, all of my options switch over to options to manipulate in this graphing tool. If I click over here and go to values, I can, of course, query the actual values or just look in the table here to see, okay, this is my starting value. These are all the values that I have plotted across this line, and here I end, and it is correctly pulling the endpoints. A couple quick tips for how to get around in HyperGraph if you haven't used it before. You'll notice in this case, my legend is totally blocking useful information. If I just click on the legend, I get a set of options here to do things with the legend. One of them is move them different quadrants in order to make it so I can actually see the information that I'm plotting. Other things here, if you want to continue to plot and overwrite this, and you don't want, maybe you plotted something here by accident, you'll need to go in here and just, within this plot session browser, shift and delete these curves. That will make this show up as blank so that anything you plot will be put on this plot as opposed to making new ones and filling your whole screen with graphs. couple other options within the linearize and extract tool that I wanted to point out. We'll go ahead and make this guy full screen again. I think we're done with hypergraph for the time being. You can do additional path definitions. So if I wanted to add a new path, maybe I want to go, in this case, from first node to last node, and we'll go again with 9. I can do that. If you want to select multiple things to plot at once, you'll have to control select. And now when you plot, you'll get the same information because all we've asked for is the stress in X, but you'll get it for both path 1 and path 2. They will be nicely labeled